Hello, everyone. Welcome, as always, to Code Labs. Really excited to have you with us today. I'm going to jump right into it. Today, we're going to be talking about something called getting your project on the web with Docker. I said web, it doesn't technically have to be web. Docker is a really useful general purpose tool. It's super neat, and we're going to be talking about exactly how it works and what the benefits are and all of that today. So like I said, we're just going to kind of jump right into it. Here's my question for you. Has this ever happened to you? Just you install a new computer, brand new, you set up your Windows computer and your Mac computer, your Linux computer, whatever it is, and then all of a sudden you spend just a ton of time installing apps, right? I think that's something that all of us have experienced. It's this sort of like, you have to get your computer set up just the way that you want it, and every single time you've got to do that. And you can imagine that that's even more of a problem when you start to have things like, you're building software, and all of a sudden you have 1,000 servers, and someone's going to set every server up exactly the same. That's not ideal, right? Because what if you miss something, and then all of a sudden, 99 of your servers are working properly, and one of your servers isn't? This actually kind of happened to a hedge fund, sort of like a group of investors that deals with a lot of money. They had some sort of algorithmic bot that was running, and one of the servers didn't quite get one of the files was not copied over right, but the rest of them were, and they ended up going bankrupt because of this one server that wasn't set up properly accidentally traded away all of their money in the course of a few hours. So most people are not going to have that problem, but at the very least it's annoying, right? Really annoying to deal with all those installers. So what if instead of dealing with all those installers, we had something like this? We had something where we give it some system where we give it a set of, here's what we're going to install, and here's the files that go along with our app. And then some sort of magic happens. Who knows what magic that is? I do, but we'll get into that later. And then it sort of outputs like a CD, right? And so you take this CD that has a combination of all of the things installed and all of the app files, and it's already all ready to go, and you just put it in a computer, and all of a sudden you have your Windows desktop running with all of your programs installed. What if that were possible? For those of you who've used Linux, we would call this a live CD, right? And it's something that you can kind of get. You can get a version of Linux that boots right into the desktop from a CD or more, likely a flash drive, right? But even so, if you want to install a program on that, you would need to do it every single time you started it up. What if there were a way that we could do this? And again, we're probably not going to do it for the desktop. I think we could. But for those servers where we have thousands of them, what if we could take this and make it something that's possible? And we can, and that thing is called Docker. So that's really the problem that Docker is there to solve, is it takes this list of stuff to install and your app files, so your .C# file or your .java file or your .python file. It does some magic and it outputs one of those images that can just be sort of put on a computer and run immediately. And so rather than the magic, what we're actually doing is something called Docker build. Docker build will, allow us to go ahead and just take the list of stuff and the app files and turn it into one of those images. And that the list of stuff that we're talking about is typically called a Docker file. So for Docker, that's the configuration is all, the list of things to install is all kept in this Docker file, which is something that we will talk about in just a bit. Additionally, the app files, we just put them in the folder alongside the Docker file. So we basically will end up with a folder with a bunch of text documents, which is super neat. And then rather than outputting a CD, because no one uses those anymore, instead we will output something that we call a container image. Docker deals in these things called containers. We'll get into exactly what that means in just a bit. But the important thing to realize is that with Docker, rather than having this list in our heads of, oh, hey, I need to install that web server, and I need to install, X, Y, and Z, I need to install these dependencies, I need to update Windows to the latest version, but actually I need to update to one version back because there's a bug. Rather than any of that, we just make that sort of live CD that runs the entire operating system as soon as we put it in a computer. And there's ways to make that more efficient, but the cool thing is we have just this set of files that can do it all for us, and it's sort of it's very reproducible as you can imagine. It's very nice that you can just continuously reuse it. So we would give this container image to a computer, and more specifically, we would actually put this container on the Docker boat. If you notice in the logo, it was a whale holding a bunch of containers, right? So the computer is running Docker, the Docker server, and we take that container image that we just made, and we just tell the Docker server, which is, you can imagine again, that whale with all the containers on its back, hey, I want you to run this image. And then all of a sudden, you're able to, again, boot into this Windows version that has all your things reinstalled. Or in our case, we're going to be talking about apps a little bit more specifically. And it's not just, again, about that desktop operating system. So if we have a website, which there's no universal logo for websites, so I'm using the Firefox logo, but we're not running Firefox, we're running a website. If we have a website that, a web app even, that we have put in one of these Docker containers, we can run it on a server. And now all of a sudden, rather than having to, buy a server ourselves, or to tell a web hosting provider or find a web hosting provider that meets our requested requirements, all we need to do is tell Docker, hey, this is this thing that I want to do, and it's going to go ahead and make sure that it automatically happens, which is super, super neat, and is really, really great, because we don't need to worry about making sure that it's got all these things installed. It'll just work. And the other cool thing about this is that we can run more than one of those Docker containers on a single server. So if we want 3 versions of our app running, we could do it. I don't know why we'd want that, but we can. If we want, 70 versions of our app running on the same server, the exact same app, we could do that. We could run our app on different computers reliably. So again, remember I told you maybe you have 99 servers that are running the same version and one that's running something different. That is not ideal. With Docker, we can make sure that every single server is running the same image, which is guaranteed to have the same version of all of the software installed, because we told it to install it and we built that image, and that image is what's getting run. It's not even the config file. We save the image, and so that image is what kind of gets cloned every single time and run on each one of these. So we make sure that it's exactly the same. And you can also run different containers that you didn't make. So for example, we could have MySQL, which is a database. We could have Redis, which is kind of a database but often used as a cache. And we can have Firefox. All 3 of those can be running in their own containers on the same server. But the really nice thing about that is, if you've ever tried to install MySQL and a bunch of other dependencies on a server, it can take you a while. And so you could package your app up with MySQL, or maybe you could just run MySQL in a separate container and then different apps could use it. But all of them can be running on the same server. Maybe you have 6 unrelated apps, and rather than buying 6 servers because they have some incompatibility in versions, one of them only runs on Red Hat Linux and one of them runs on Ubuntu, all of a sudden with Docker, that's no longer a problem. These are all things that you can do. Now, I know what some of you might be thinking. Remember, each one of these containers has its own operating system. And so I know that you might be thinking, hey, wait, isn't that a little bit inefficient to have 3 different entire operating systems running on this machine at once? And the answer is it would be. But one of the other cool things about Docker is that it actually only runs like 1.1 operating systems, right? So it runs like one operating system that's the server itself. And then rather than actually each one of those containers having its own operating system, it sort of like translates things over to the main operating system. So it's a little bit more efficient than that. It's not going to be as efficient as you might think. This will actually run reasonably fast. It's not just an imaginary thing that we could do, but we don't, because it's not a good idea. It actually turns out it's a pretty reasonable idea and it's pretty easy to do. So let's start getting into what a Docker file actually looks like. Because we were talking about, again, if we go way back to this diagram back here, we have this Docker file. What does it look like? The very first thing we need to do is we need to tell it what base this is coming from. And so the simplest version, we'll talk more about this in a minute, the simplest version is just pick an operating system. So I could pick Ubuntu. If you've ever heard of Linux, there's a good chance you've heard of Ubuntu. I could just pick Ubuntu and say, hey, I'm going to use Ubuntu. This is what everything is going to be based on. I could also say the next thing that we're going to need to do is we're going to need to install some certain packages. And so if you're familiar with Linux, you might have seen some of these commands here. If not, that's totally okay. But the first thing we're going to do is we're going to say run. So it's going to be run right over here. Apt-get update. And what that's going to do is inside that container, while it's still building, not once it starts up, but while it's still building, when we have this image, it's already going to have all this stuff done. So while it's still building, it's going to run apt-get update. The next thing it's going to do is it's going to run apt-get install Python pip. I'm shortening it, but it's going to install those two things, Python and Python pip. And then it's going to run pip install Flask. Now, if I were doing this on a computer, what I would do itself is I would say pip install Flask. That is what I would do. This run command is specifically telling Docker, hey, I want you to run this thing inside the container. So the container is not going to get run pip install Flask. The container is going to get run, or the container is just going to get pip install Flask. Docker is understanding that run thing. I hope that that makes sense. That's really one of those things that's a little bit, you need to understand it. None of these things are magic. None of these commands are magic. If I wanted to, I could do run rm-rf, which would remove everything. rm-rf/. I could run echo hello world, and when it builds, it would run echo hello world. Any of these are just Linux commands, and run just tells Docker, hey, when you're building this image, go ahead and run this command. Now, the next thing that we're going to do is we're going to copy our files in. And the way you do that in Docker, there's two different commands for it. They have very slight differences, but don't worry about exactly what they are for now. You can look them up later if you need them. But we're going to run add app.py, and then we're going to copy that into the /app/start.py folder. So to really understand what's going on here, remember this Docker file is saved in a folder. In that same folder, we have a file called app.py. After Docker has already gone ahead and it's run this apt-get update, it's run this apt-get install, it's run this pip install Flask, now what it's going to do is it's going to, in the same folder as that Docker file, copy the app.py into the image that we're building here, into this container. Again, it's a container. It's going to copy that into the sort of virtual file system, the virtual disk inside that container at the location /app/start.py. So it's getting copied from our real disk into this sort of imaginary disk that exists inside this container image that we're making right now. I hope that that makes sense as well. Lastly, we tell it where we're going to sort of run from whenever the image starts up. Where is it going to run from? And then finally, we say the command that we want it to run whenever it does start up is python start.py. So basically, whenever the image starts up, whenever we run, even if we're running 50 of these, each individual one of them will start running in the /app folder on its virtual disk, and it will run the python start.py. Now this is different from run. Up here we see run. What the difference is that run is just going to run when we're building that initial image. So remember, we're building like a version of Windows that has all of our things pre-installed. You can think of it as that, right? Run is those things that we're pre-installing. CMD is going to say, hey, and also, whenever it starts up, automatically launch this program. If you've ever had, like, you have Skype installed and you start Windows and Skype automatically opens, or, Signal or Telegram or something like that automatically opens, that's the difference here. Run is like the installer for Skype or Signal or Telegram or something like that. CMD is saying, and also automatically start it whenever the computer starts up. So whenever the computer starts up in this case, we want it to run our Python app. Now, we were talking about how earlier on this page, we were doing from Ubuntu latest. So we were saying we're going to base this on Ubuntu. The other thing that we can do instead is we can actually extend other images, other container images. So we can say from Python latest. And Python is a container that is built into Docker. It's a container image that's built into Docker that basically is an operating system with Python already installed. So you can see how we sort of saved ourselves these lines of code from saying run apt-get update, run apt-get install Python pip. all we've done is all those first 3 lines are turned into now from Python latest. And you can go online and you can find the Docker file for this Python latest container. And you can see that, in fact, it will basically do those things. It'll do a few other things for us, too, that we don't really need. But it's pretty convenient, and it means that you can kind of build on top of each other. So it might be a lot of work to set up a container that can run the latest version of C# on Linux. At least it used to be when I was trying to run C# on Linux. So if you want to run a C# website without a Windows computer, it'd be a lot of work. But somewhere online, there's a .NET container that will do this all for you. It will automatically find the things, and it'll install them all, and it's already done. And so all you would need to do is say from that container, and then whatever commands that are specific to your specific thing. So in this case, Python comes with a lot of stuff pre-installed, but it doesn't have Flask pre-installed. So what we would do then is we would run the pip install Flask instead of everything else, and then we would just add our app files, and we would tell it what to start when it runs. So that's another thing that's really neat about Docker, is this concept of extending. And the nice thing about this is, too, it can cache Python latest. So rather than needing to rerun a bunch of commands that might be slow every time, any container that extends from Python latest is going to have those commands automatically pre-installed. It's not something that we need to do every single time. It's very convenient in that sense. So once we have this Docker file, the next thing we need to do is build the image. Remember, there's sort of a difference between an image and an actual container, which is that an image is the thing that we can start, and the container is it actually running. It's kind of the difference, again, between the image is like that CD or that flash drive that contains the information on how to boot Windows. Like, the Windows is everything's already pre-installed, but it's not turned on yet. And the containers are the actual instances of it running. If you've ever heard of objects versus instances and object-oriented programming, it's kind of the same thing. The container is more like the object, and the running versions of it are like the instances. So in order to actually build our image, we just go into that directory where we have our Docker file, and we say docker build, and we say -t and give it a name. So I'm just calling it my app in this case. And then we put a dot here, and that just says build the current directory. So we're going to build the current directory, that one with the Docker file in it, and we're going to call it my app. So what that is going to do is Docker is going to go out from that Docker file that we just had. It's going to grab the Python image. It's going to run all those commands in the Docker file on top of that Python image. It's going to copy in start.py. So all 3 of those pieces, the Docker file itself with all the commands, the Python image, and the start.py, Docker build will go ahead and combine all 3 of those into this my app image, which is a container. It's not actually on a boat yet. It's just like an image of a container, and we can make as many copies of it as we want, but now it exists. Now we want to actually run it. So what we do is, in the simplest version, Docker run my app. And what Docker is going to do then is it's going to take that my app image, it's going to make a copy of it, and it's going to put it on the boat that is Docker server. So that's kind of those containers, again, sitting on top of the whale. You can think of the whale kind of like a server. And it's just all its job is to make sure that all those containers are running and to understand how to run them. So when we run that Docker run my app, what it's going to do is the Docker whale is going to go and pick up a copy of your container and start running it. Now, in our example, let's say that it's a web server, because again, we were talking about getting our project on the web with Docker. So what if we wanted to have 2 web servers? Well, that's a problem, because both of them can't be running at the same time, right? Both of them can't be listening on the same port. And so by default, what Docker does is it doesn't allow anyone to listen for network connections. I'll tell you right now, it's possible to run things that don't need to listen for network connections, but probably 80 to 90% of things you would want to run on Docker will want to receive incoming network connections, because this is usually used for like web applications. Now, it's not always the case. So as an example, on the SR&D chat, we have a bot called John Peter, and John Peter does not need to listen for incoming web requests because it's a bot. It doesn't have a web interface. It only makes outgoing commands, and it listens on it in our chat room. So that one doesn't have any port forwarding. But in general, most apps will. And so what you'll need to do is you'll need to manually tell Docker to port forward things. Now, port forwarding is an entirely separate concept. If you're not familiar with that idea of port forwarding, I would recommend just sort of looking that up in general. It's something that you might do, for example, if you have like a gaming console especially older gaming consoles like Xbox 360 generation, you might need to do it with your router. Docker is kind of doing the same thing as your router internally. So again, if both of these were listening for a web request, there'd be an error. So Docker, what we would just do is we would manually tell it, hey, this container is going to listen on port 8001, and any request it gets is going to go to port 80. This container is going to listen on port 8002, and any request that it gets is going to go to port 80. And so on and so forth. And we could run as many of these as we wanted, up to the maximum port limit, which is 65535. We could really run a lot of these containers. Now, if we wanted it to listen on the default web port, that's usually 80. So what we would do is docker-p 80:80 run my app. And that would be how we would make it listen on the default web port. And I think that is my last slide. It is. So we're actually going to go into an example. So we're going to go into the Docker test example that I've already set up. And I'm going to go ahead and remove this Docker file that's already in here. So what we do have is we have this application. And this application, if you were in the Flask workshop, you might be familiar with this. This is something that is definitely a very simple web server, and all it's going to do is it's going to return hello world whenever you see it. So very, very simple application. What we're going to do, we're not going to go through the process of coding this. If you want to check that out, check out the workshop on Flask and Python that we did on, I think, last Friday. But what you're going to want to do is we're going to go ahead and edit a Docker file. And don't worry about this editor in particular. This is called Vim. You can use whatever text editor you want. I'm going to use this because it's easy. But again, you can go ahead and use any text editor that you feel like. So let's. Oops, I just locked my computer 1 second. There we go. Okay, well, I can't close this sidebar because the key bindings are different now, but that's okay. So what we're going to do is we are going to go ahead and make our Docker file. Now remember that first thing was from, and by convention we usually use uppercase. I don't know if it's required or not. From Python, latest. Now why would we do latest? Well, that's always going to pull in the latest version. Maybe we want it to be a specific version, but that's up to you. So from latest we need to run pip install Flask, because we want to have Flask, which is our web server package. We're going to add app.py. I'm just going to copy that into the /app.py because it's easier. And then our startup command is going to be Python /app.py. I'm going to go ahead and save. This is how you save in Vim, but again, no need to worry about that specifically. And now what I'm going to do is I'm going to build our image. So I already have Docker installed. If you don't have Docker, that is a process sometimes. If you're running Windows, if you're running Mac or Linux, it's a lot easier. There are good tutorials on that online. I'm not going to go through it for every individual operating system. It's not difficult, it just takes a while. But it's worth installing. Again, also you could run Docker on a web server, and that would solve some of these problems. But in any case, we're gonna go ahead and move on. So what I'll run now, everything up until now we haven't needed the Docker command for. We will actually run the Docker command now. Docker build. Again, we're going to give it a name. I'll call this Docker test. And dot, which means build in the current folder. So look for that Docker file and that app.py in the current folder. And you can see that it just ran very, very fast. And the reason for that is because this image, Python latest, was already cached. And remember how I said that Docker would sort of reuse existing images if possible. So that was really, really, really fast because it's already stored locally. And you can see that I have already on a Python latest container run pip install Flask, and so it says using cache. And the same is actually true more or less for app.py and this one as well. And it works that way because it noticed that app.py is exactly the same. So you can see that I've been testing this before. But it shows that if you haven't made any changes to a certain stage, it's not necessarily going to be slow, which is a really, really nice thing. It means that if you if we go back into this Docker file, you can see that there's the first command and the second command and the third command and the fourth command. And if the first, second, and third commands are all the same and nothing has changed there, then it's the fourth command is the only one that's changed. The first three are going to be very, very fast, which is super neat, because it means that we don't need to worry about, if you're installing a lot of packages and they'll take a while, and then you make a change to your application later, so that copy command needs to change. Well, everything else is going to be fast. And in fact, let's actually go ahead and test that out. So app.py, let's say that we, just add a comment down here, hello. You can see that now when I rerun this Docker build, it took a little bit longer. This add command took a little bit longer, and it doesn't say using cache anymore. This command took a little bit longer. It doesn't say using cache anymore like it did up here. But the first two were still cached. So even if it's really, really slow to install a bunch of packages, Docker will keep those in mind, which is super neat. It also means pay attention to your ordering. Because if you have your first one on top, it's going to be a little bit slower. So with that in mind, the next thing we need to do is Docker run -p. We need to give it a port number, so I'm going to do 8070 just for fun. I made it up. I happen to know that this will by default listen on port 5000, so that's what Flask is configured to do. And then I give it our name, which is Docker test. Hit enter, and you can see that it's all running. So without even installing Flask on my computer, I think it is installed, but it doesn't have to be. I could uninstall Flask. I could uninstall Python. Without any of that being true, it's automatically working. All of this is automatically in there, and it's able to run our web server, which is super neat. Now there are some other things that you can do with this. So there's also a thing called a Docker compose file. And if you want to run multiple Docker containers and you want them to all be stored in the configuration itself, what containers are running, you can use Docker compose. There's a really neat system called Docker Swarm. And so if, for example, I were to, didn't configure that right, but if I were to SSH, let's do this. Give it a second. There we go. So this computer is actually running Docker. And if I see Docker services ls, I think it's Docker service ls, you can actually see here are all of the SRND services, which is, again, very neat. So all of these, though, are not all running on the same computer. There's actually a few computers. So this one, if I do Docker ps, which is another Docker command, you can see that it's got a bunch of servers running on this one. Let's see if I can zoom out to a reasonable size. That's okay. So you can see this one's got some servers running on it, but not as many as there were. And if I SSH into the second computer that's in this Docker swarm, and run Docker ps, you'll see that it actually is running a different set. Some of them will be the same because that actually gives us redundancy. So if one of them goes down, then we don't have to worry about it because it's going to be running on other servers, and Docker will automatically notice that. So you can use these Docker containers to add redundancy or to automatically load balance, which is another really neat thing that is a reason why this is really popular. There are other things, by the way, that are actually a little bit more popular than Docker Swarm for doing this, but they'll still take Docker containers. If you've ever heard of this thing called Kubernetes, which is a really complicated thing to set up, but it's very popular right now. It's what Google uses for a lot of their internal services, and it can still take Docker containers as kind of an input, which is super neat. So with all of this, we can actually store a lot of information about our applications and how they run in these containers, and we can run them in very flexible ways. You can imagine how before, sometimes if you wanted to tell someone how to install your app, you might have to say install X package, install Y package, install this program, run it in this particular way. And now with Docker, all you need to do is say, hey, all you need to do is grab this Docker container, Docker pull, and then the name of the container once you've published it to the public Docker repository, which is kind of like a GitHub just for Docker images, and say pull that, and then just Docker run it, which is super neat. if there's things that need to change, like different like private keys or like encryption keys or something, you can pass those in with something called environment variables. And so you could actually have, for example, maybe you have an environment variable for production and staging. And so if you have a popular website, you could all of a sudden have a version of the container that has the production version and a testing version that's still running on Docker on the same server, which is, again, very, very, very neat. So with that in mind, I'll switch over to my video here. That is the gist of Docker. It's a very, very neat tool for helping you manage your web server configuration, your web application configuration, your API configuration, as we'll be talking about tomorrow in the API workshop, keeping track of all of them, and making sure that everything is always running in the same way, and that it's easy to run it, and that it is something that can be repeated reliably. So with that in mind, I hope that that's something that you do end up giving a try. If you have any questions, post them in the SR&D chat. It took me a while to understand Docker. We did a workshop on this last year. Our intern did it, and I didn't understand Docker at the time even. It took me a little while to get it, but once I did, it is a very, very powerful tool. It's really cool, and it'll save you a lot of time in the long run if you ever get into things like servers. So with that, again, if you do have any questions, post them in the SR&D chat. Chat.srnd.org, and we hope to see you for the workshop tomorrow on API design. So thanks for joining.